Hey, boys and girls, welcome to Mrs. Walker's sixth grade virtual science class. And the standard that we're going to cover today states to construct explanations for how gravity affects the motion of objects in the solar system and the tides on Earth. So the key concepts that we are going to focus on is what is gravity, what determines the strength of the force of gravity between two objects, and how does gravity affect the motion of objects in our solar system. Why does the moon orbit the Earth? Newton hypothesized that the force that pulls an apple to the ground also pulls the moon toward Earth, keeping it in orbit. This force, called gravity, attracts all objects towards each other. In Newton's day, most scientists thought the forces on Earth were different from those elsewhere in the universe. Although Newton did not discover gravity, he was the first to realize that gravity occurs everywhere. Newton's law of universal gravitation states that every object in the universe is attracted to every other object. The strength of gravity. The strength of gravity is measured in units called newtons, named after Isaac Newton. The strength of the force of gravity between two objects depends on two factors: the masses of the objects and the distance between them. According to the law of universal gravitation, all of the objects around you are pulling on you. Why don't you notice this pull? Because the strength of gravity depends in part on the masses of the objects, and the mass is the amount of matter in an object. Force of gravity. Because Earth is so massive, it exerts a much greater force on you than a book does. Similarly, Earth exerts a gravitational pull on the moon, large enough to keep the moon in orbit. The force of gravity on an object is known as its weight. An object's weight can change depending on its location. For example, on the moon, you would weigh about 1/6 of your weight on Earth. This is because the moon is much less massive than the Earth, so the pull of gravity on you would be much less. Inertia. Inertia is the tendency of an object to resist change in its motion. To resist change in its inertia, which is changing in its motion. Isaac Newton stated his ideas about inertia as a scientific law. Newton's first law of motion says that an object at rest will stay at rest and an object in motion will stay in motion with a constant speed and a direction unless acted upon by a force. How does that apply to this? Well, all of the objects in our solar system have inertia and they have tendency to resist change in their motion. But what causes those objects to not go in a straight line is the gravitational pull of the larger objects like the sun. So the reason the Earth rotates around the sun is because the sun's gravitational pull causes it to go in that circular motion. Why do Earth and the moon remain in their orbits? Newton concluded that two factors, inertia and gravity, combine to keep Earth in orbit around the sun and the moon in orbit around the Earth. Earth's gravity keeps pulling the moon toward it, preventing the moon from moving in a straight line. At the same time, the moon keeps moving ahead because of its inertia. If not for Earth's gravity, inertia would cause the moon to move off through space in a straight line. In the same way, Earth revolves around the sun because the sun's gravity pulls on it while Earth's inertia keeps it moving forward. Why do the planets remain in their orbits? The sun's gravity pulls the planets toward the sun, which changes the straight line of direction into a curve. This keeps the planets moving in an orbit around the sun. Because the sun's gravitational pull, all of the planets in our solar system orbit around it. And you can see here in this image, I have the sun and I have all of our 8 planets. And hopefully you remember those planets in order from the sun out, from learning that in 5th grade. And you know which ones are the inner planets and which ones are the outer planets and which ones are the terrestrial planets and which ones are the gas giants. And what is the asteroid belt? Those are all questions you should be able to answer. I do have a video resource that I want to show you next from Twinkle Go.
Movement of the planets in our solar system. A solar system is a star and all the objects that orbit around it. These might include planets, asteroids, moons, and comets. The star at the centre of our solar system is called the Sun. and it is a ball of hot gas. It gives out heat and light. It is the gravity of the Sun which keeps the planets orbiting around it. There are 8 planets orbiting the Sun at different speeds. Mercury takes 88 days. Venus takes 225 days. Earth takes 365 days. Mars takes 687 days. Jupiter takes 12 years. Saturn takes 29.5 years. Uranus takes 84 years. Neptune takes 165 years. Each of the planets orbiting the Sun also spins or rotates. The Earth takes 24 hours to rotate on its axis. The planets have their own gravity, and some have objects, such as moons orbiting around them. The Earth has one moon, which takes 28 days to complete an orbit around our planet.
Monster.
All right, let's get back to our slides. I'm having a loading issue. It's not what I meant to hit. There we go. All right, so the next thing that we are going to discuss is our tides. And our tides are directly affected by the gravity of the moon. Once or twice each day, ocean waters rises and falls at every beach around the world. This repeated rise and fall in the level of the ocean is called tide. Tides are caused by the pull of gravity of the sun and the moon on Earth's waters. Since the moon is closer to the Earth than the sun, it has a greater effect on tides than the sun does. So you can see right here our moon, and we have this image of the Earth. And what takes place here is, the moon revolves around the Earth, and the Earth is rotating on an axis, and those oceans have sea levels that can and water that can move around in waves, and the moon has a gravitational pull that pulls that liquid towards the moon. As you know, solids are tightly packed particles, so it doesn't affect our land masses, but it does affect our oceans because they have the ability to move. So you'll see this blue outline here represents the bulging of the waters, and it occurs on the side where the moon is and then the opposite side, and the low tides occur just above and below or perpendicular to wherever the moon is. And it's because this water is being pulled this way, it's being pulled this way, and the Earth is also spinning, so that affects it as well. So high tides and low tides happen in coastal areas, and they happen at regularly predicted times. And they typically there are 2 high tides and 2 low tides in any given day. So that is the way gravity and the moon affects our waters. All right, see you next time. Thank you for joining me.